Hello everyone. Today I'm going to show you the mathematical definition of a derivative. And in order to do that, I have drawn this curved graph and I have selected 2 points on the x-axis. And I have defined the corresponding values on the y-axis, which would be f of x1 and f of x2. So what I'm trying to find here is the rate of change of f of x, which is again the same as y, with respect to x. So now we can use this formula to basically define the rate of change of f of x with respect to x, and that is going to be very easy. So f of x2, which is here, minus f of x1 divided by x2 minus x1. And also this can be written as the delta x, and the delta x is from here all the way to here. So that is our delta x. Now this is a very crude version of our rate of change, and when we look at our graph, the rate of change that we have calculated is going to be basically for this red line. So it is not going to be exactly for the curved line. As you can see, there is a little bit of gap between the red line and the blue line, or the curved line. So what we are doing next, if we move our x2 slightly closer to x1, you can see the difference between literally the straight line and the curved line is going to be reduced significantly. So and as we go further, closer and closer to x1, we get to a point that we see that literally the rate of change on the red line is going to be very close to the rate of change on the curved line. So now that we have found this, we tell ourselves, all right, then maybe x2, it's not actually worth it to be in our formula, so we can write our equation based on only x1 and delta x, because it makes more sense. So what we do next, we try to write our equation, our f of x2, based on x1 and delta x. So our x2 is going to be basically equal to f of x1 plus delta x. So f of x1 here plus the delta x is going to give you f of x2, and hence we can write this equation in this format. So that is going to be f of x1 plus delta x minus f of x1 all the way to delta x. Now that we have discovered this, you may ask yourself, all right, what's going to happen if we, make the difference between x1 and x2 so small, so that we can make it literally 0. So if you do that, if you make delta x 0, you're basically not achieving anything, and your whole equation, your whole formula is going to be literally meaningless. So in order to avoid doing that, we have to use limit, and we have to set a limit saying that, all right, our delta x is going to approach 0, but not exactly going to be 0. So then we can set a limit on our function, on our entire equation, which would be f of x1 plus delta x minus f of x1 all the way to delta x, when delta x is actually close to 0. And I've come across a few situations where students basically confuse themselves of writing this f of x1 plus delta x in this way: f of x1 plus f of delta x. So this equation and this equation are not the same. And I give you a numerical example of that so you can see it clearly that they are not the same. Let's say our f of x is equal to x to the power of 2 plus 1. Imagine our x1 is equal to 1 and x2 here is equal to 3. So f of 1 would be equal to 1 to the power of 2 plus 1 is equal to 2. However, f of 3 would be equal to 3 to the power of 2 plus 1 is equal to 10. So now f of delta x, which is going to be f of 3 minus 1, which is going to be 2. So then our equation would be 2 to the power of 2 plus 1 is equal to 5. And hence f of x1 plus f of delta x is equal to be, so f of x1 is this one, so that is going to be 2 plus f of delta x, which we define here as 5, is equal to 7. Alright, now let's calculate this one, f of x1 plus delta x, which is again from we haven't basically done that, so that would be is equal to f of x1, which is 1, plus delta x. So delta x, as I said before, delta x is equal to 3 minus 1 is equal to 2. So that would be is equal to f of 3, which is equal to, and we plug in 3 into our equation. We plug 3 into our equation. We receive 3 to the power of 2 plus 1 is equal to 10. So now, as you can see, these two are not the same. Therefore, f of x1 plus delta x is not equal to f of x1 plus f of delta x. Please do not make yourself confused. So these two notations are basically completely different and they are not equivalent. Hopefully you've learned something new, and I'll see you in the next video. Bye.